Hello, welcome to the lecture on programming in C. In this lecture, we'll be talking about computer organization. Okay. So, what we mean by computer organization is we will go through the different hardware components and how they are arranged or how they are connected. To each other. Okay. But before going into that, I'd like to go through what is called as a functional view. Of a computer. Okay, what is meant by a functional view of a computer is we'll divide the whole complete hardware resource into certain groups, and we'll see which of the groups are involved in what kind of basic operations that is done by a computer. Okay, so starting with the functional view, we are dividing our whole complete resources into 4 groups. The first one and the most important one is a control mechanism. Let me draw it like this. Then we have what is called as a data movement apparatus. Data movement apparatus. Right. The data movement apparatus. Then we have the data storage facility. And after that we have the data processing facility. Okay, so this control mechanism is constantly in communication with all 3 of these, right? That is the data movement apparatus, data storage, and data processing. All of these are in constant communication with the control mechanism, and it is by its name itself you can understand that control mechanism is the most central part, and it controls everything. It controls all of the 3 major functions or components. Okay, now the first function that I want to talk about is the data storage. Okay, that is number 1. What is happening here? We are using the data movement apparatus. Okay, we are using the data movement apparatus to move data to and from the storage facility. Right, the storage facility, what is basically it can be memory, or it can be let me just write it here, memory, right? It can be the RAM, primary memory, or secondary memory. And what is this data movement apparatus? It is basically what we call as bus. Okay, we'll come to that. So what is happening? We are storing data, and to store data from somewhere we need to take it from somewhere, and we need to utilize the data movement apparatus, and we have to use the storage facility, and always the control mechanism is involved. Okay, the second type of process that I want to talk about is the data movement. Data movement. Here what is happening? here we were taking something from maybe something like an input output device, or yeah, input output device only, and we were storing it into data, or we are taking some data from the storage and moving it to the input output. That was the first part. In data movement, what is happening is we are not storing it in the memory. Instead, we are taking from one part to one input device to the other, right, or one input device to the output device. That is, we are not storing it, but we are moving it from one part of the system to the other. Okay. The third one is the data processing from storage. Okay, that is, you are taking some data from the storage, we are processing it, and then we are putting it back. Okay, that is data processing from storage. Okay, we are taking something from the storage that is already stored in the system, we are taking it, we are processing it, and we are putting it back. And what could this be? The data processing facility, what it is usually the CPU. Not usually, it is the CPU. Okay. And the last one, the fourth one, which is we are taking data from the data movement, we are processing it. Okay, number 4, which is data processing to or from storage and IO. Okay, that is, earlier we were taking some data from the data storage itself and we were processing it and we were putting it back. But here what we are doing is we are either taking some data from the storage, processing it and giving to the IO device, or we are taking something from the IO device, processing it and putting it into the storage facility. Okay, so this is a basic let's say a rudimentary classification or a basic understanding regarding what is happening in a computer. So many of the things happening in a computer, it can be explained using these 4. So in this you can see that some sort of data movement is always happening, right? And that data movement can be from an input output device, it can be from the storage, it can just be some data movement, that can be some processing, there may be some processing, there may not be some processing, but the thing is almost always some sort of data movement is happening. Okay, that is the this is the, what is it, the functional view. Functional view of a computer. Okay, now let's move into the proper computer organization part. Okay, so what do you mean by computer organization? We want to see how the different the hardware components are connected, or how they are interacting with each other to establish the goal, that is executing instructions, right? Okay, so now let's I'll just draw the diagram first and we'll see the components one by one. Actually we have seen some of the components earlier. So the first one is the control unit, right? Then we have the ALU, and we have the registers. Okay, so these three combined this is the CPU, central processing unit of the computer. This is what we call as, or simply the processor, the microprocessor or whatever. This is the basic processor, that is a control unit, an ALU and registers combined. Okay, so these okay, this communicates with the outside world with what is called as a data bus. So what do you mean by when we are saying outside world? We have our memory. Okay, we have our memory. Then we have our input devices. Multiple input devices are there. I'm just showing it as one box. And we have our output devices. Okay. So we have, so this is a basic computer system. So we can divide this memory into primary and secondary, or we'll come to that later. We'll see memory in detail a little bit later. So this is a basic computer system. We have the CPU. So we have the CPU, we have the memory, we have input devices, we have output devices. So what is the components of the CPU? We have the control unit, which controls everything. This actually control unit is the brain of the computer. Okay, we have the ALU. Okay, ALU, we just write down things to explain later. We have the registers. I don't think control unit needs to be explained any further because it is self-explanatory. We have the bus. We have memory. We have input-output devices. Okay, so this is the interconnection. So this two double-lined connections, whether it is one direction or two direction, this is used for data, and a single lined connection are used for control. Okay, so actually you can elaborate this in a sense that, okay, this there is a control flow between what do you say, this processor and the other devices. There is a control flow between the processor and the ALU and the processor and registers. It is there, and also there is a data flow between internal data flow between the ALU and the registers. This is also a bus. Okay, so I'm not showing this. Okay, I'm not showing this. So basically understand, there is data flow between the CPU and the other devices, and there is flow of control between the control unit or the CPU and the other devices. Okay, so now coming to the different components. So ALU, What is ALU? The full form is arithmetic and logic unit. It is used to what is it used to? Perform what? Arithmetic and logic operations. Okay. It is used to perform arithmetic and logic operations. So where does it arithmetic operations means like a plus b, a minus b, a and b, a XOR b, things like that, logical operations, whatever. So it requires this operands, right, a and b, and also the result has to be stored somewhere. It is equal to something, right? The result has to be stored somewhere. That is where the registers come in. It is for the temporary storage of data. Okay, always data flows into the ALU and from the ALU between registers, that is input to input to the ALU is given from some registers. Let's call this register A and register B, and the output is taken sometimes to some other register or maybe A itself. Okay, so always the data transfer to and from the ALU is to registers. Okay, it is used for temporary storage of data. This data can be of multiple types. You don't have to go into much detail for this course. You will learn that in much detail in your computer or architecture or computer organization course later. Understand, registers are an integral part of the CPU. Without registers you cannot use ALU. Okay, so bus is basically used to transfer data and control. Okay, control signals, let's say control signals. That is see here, if there is some instruction in the memory, that instruction has to be transferred to the to some particular register, and then only that can be decoded by the control unit and executed, right? So that transfer of instruction, and if some data is also there, that takes place through the data bus. Okay, that bus, that is the purpose of bus. It is to used to transfer data and control signals. What do you mean by control signals? The control unit will give certain signals. It will ask the memory to do something, it will ask the input device to do something, ALU to do something. So that is transferred using the control bus. Data is transferred using the data bus. Okay. So basically bus is a collection of wires, bunch of parallel wires, only that much is there. And input output devices you already know, for the user to give in data and collect data. Okay. Then comes memory. We will see memory in detail. Okay. So before going into the details of memory, let's have a brief understanding regarding how this an instruction is executed. Okay. You may not need this for this particular course, but it will give you a better understanding or appreciation of the subject or how computers work. Okay. So first of all, we have the ALU, okay, and it is connected to the registers. Right. and we have the control unit. It controls everything. Control unit controls everything. Okay, so from the memory, right, we have memory here, and we have our bus here. Okay, so from the memory, instructions are taken and given to the control unit. Okay, I'm a little bit simplifying it. In between, some other components are there, but let's say for the sake of simplicity, let's say that instructions are taken from the memory and taken to the control unit. Let's call this step 1. Okay, the control unit decodes the instruction because it will be in a particular format in the memory and it requires to be decoded. It decodes the instruction and it understands what process is to be done. Okay, so once it knows what process is to be done, it looks for the, what does it look for? It looks for the data. For example, if the process to be done is A plus B, A and B are required, right? So where does that come from? It may come from some input device or it may be in the memory. So what it does is that data has to be taken to the memory. So that is step number 2. That is taken from the memory and into the registers. Because remember, without using the registers, the ALU cannot function. So once the processor knows what operation is to be done and it has the operands, A and B are called the operands in the registers, then that is transferred to the ALU, operation is done and it is given back to the registers. Okay, okay, let's call this 3 itself. Okay, the instruction is taken and decoded and the CPU control unit understands what instruction is to be executed. Then whatever data is required, it is taken from the memory or input output device, whatever. For simplicity, let's say it is in the memory. It is taken to the registers, and from the registers the data is taken to the ALU and the control unit tells the ALU what to do, and it is stored back into the registers. Okay, but registers are temporary storage, right? And that has to be given back to the memory or output device. Let's say, for simplicity, let's say memory. So it is stored back to the memory. So this is how and what a basic system works. And once that instruction is done, once that instruction is executed, the computer goes on to execute the next instruction in the memory. Okay, so we'll see that in a while. So that is how a basic operation runs. Now memory is the next topic that we have to see, and we'll see memory in the next lecture. Thank you.